Hello everyone. The plan for today was to get the next Voron 2 episode out, but I had some wiring problems and I worked till midnight last night working on that, and I can't work past midnight because the neighbors complain. And today I basically have Teams meetings all day. This is just like my 1 hour in between, so yeah, I really couldn't finish it, but that's definitely coming probably this Friday. But today I want to show you some of the PCB projects that I have going on. I plan to show these in their respective episodes, but it also makes sense to show them all at once as well. So yes, I have quite a few new PCB projects that I'm working on. The biggest one in my opinion, at least the most interesting one, is the PCBs I'm planning for the Voron 0.1. So you can see a toolhead PCB here. That's again just a breakout, but if we look at it in easy EDA, this is what it is. So here we have a 18 pole microfit connector here and just a breakout, but that goes to the PCB here, so the cover PCB here, which is actually an idea I stole from Timid. He actually has a PCB that's designed already for this. He uses a 14 connector version of the same connector, but other than that it's ready. It's basically a breakout plus a thermistor that's SMD soldered. Now in my view, either I'm going to go with SMD and build a bunch of components and not just a thermistor, or just design something that's completely through-hole, because yeah, I can't do SMD soldering. So if I'm going to go through the trouble of getting it assembled, I might as well build more functionality or just build something through-hole. And for that I actually have a cover PCB design as well. This guy, as I said, this is inspired by his thing, but you can see that this is quite a bit more complicated. And what's going on is I have these module buck converters, so 12 volt and 5 volt. So once you input 24 volts, it generates 5 volt and 12 volt rails, so that powers the Raspberry Pi. And if you want 12 volt fans, that also powers that. So that means you don't need buck converters. This is kind of inspired by the spider board that I have for the Voron 2.4. But yeah, you can see the voltage selection here, for example, in the same idea. And on the back, as I said, this has an 18 pin version of the minifit. And here is a NeoPixel stick mount that I'm probably going to get rid of actually, because it just is too crowded. And here it's a Bosch BME 280 mount, one of those module versions, because you can see that there are no assembly components on this. So yeah, I might as well use a module at that point, but I am considering changing that. Basically, the power buck converter modules are pretty expensive and pretty difficult to get, and if they get discontinued or go out of stock or anything, well, they will be difficult to replace. So I might also go with a usual, just build everything into the PCB using, I don't know, LM2596 buck converters or something like that. So if I do that, then I'll just build in the BME 280 or 680 or just a thermistor on the PCB as well. But this is what I have right now. As I said, this is still a work in progress. I haven't ordered this, but yeah, this is I think pretty interesting idea. Hopefully it will work well, but stay tuned for that. There will be more developments on this. As I said, this is just a work in progress, so for more up-to-date information, wait for the next Voron 0.1 episode. And moving on, there is the Tiny-M. So in the Tiny-M build, and the electronics chamber in the back, you can see that now I have this board. So normally I designed the cover plate here for LM2596 buck converter module, so one of those cheapo AliExpress buck converter PCBs, so that I can supply 5 volts to the Raspberry Pi. But yeah, I wanted a bit more functionality. I wanted Max 31865 boards for PT100s, so that I can get better measurements, especially important since this is a high temperature build, so I don't want to just use a regular thermistor. And I also wanted the option to select the voltage for the fans and stuff like that, so I kept the same mounting hole locations, but designed this thing to replace that. As I said, this is also in work in progress. For example, again, the buck converters, I might just change that to a more traditional, just a LM2596 or whatever, but SMD assembled, not modules in this case. And yeah, this is what I have. The Raspberry Pi's GPIO connects here, so this is also a breakout for the Raspberry Pi's GPIO. And here I have a bunch of power connectors for 24 volt, 12 volt, 5 volt, and maybe 3.3 volt, I think, as well. I have to check the schematic to be sure. And just GPIO outs here as well, so you can just connect anything you want that is GPIO controlled here. A breakout for the UART and I2C and SPI up here, but SPI will also be used for the MAX31865 obviously. So these are for the Adafruit/Adafruit clone modules. If I'm going with the SMD assembled thing for the buck converters, then I will also build those in as well, just so there aren't many modules sticking out. But the reason I went with the Adafruit clone instead of CJMCUs is because the CJMCUs are more difficult to find. I normally prefer those, but I don't know what's going on. They're really difficult to find. The reason I prefer those normally is they're smaller, but yeah, if I can't find those, I might as well go with the Adafruit clone versions. So yeah, and the fan input here, that's going to be run from the Big 3 Tech SKR Mini E3 V2.0, and I have 4 fans here, but again, you can select the voltage with jumpers here, so 12 volt, 24 volt and 5 volts, whichever one you need, you can just select it here and control the fans as you wish. So you can run a 12 volt PC fan for cooling the electronics, for example, and a 5 volt hot end fan and a 24 volt layer fan if you want to, I guess. So it just is a bit more flexible. That's why I designed these that way, and yeah, I think that's a pretty good idea. We'll see how these boards turn out when I order them, but as I said, this is still a work in progress, just like the other one I showed, so it will be a while. That's why I didn't want to show these yet, but as I said, I couldn't do much progress on the Voron 2, and I don't know if I said this or not, but the problem is a wiring problem with the breakout boards and the DB15 and the 17W2 running to them. It's just too bulky, and yeah, the solder joints get cracked and stuff like that, so I want to replace those, and that means the new PCB that I ordered for the Voron 2 I also want to get rid of and replace with something else. And this is just a very early design, not even as developed as these, but this is the sort of thing I had in mind. It's just something I threw together without actually much thought put into it, but I want to keep the DB9 because the bed side of the breakout works well, and the rails from the power supplies and breakout for those on the other end as well. So it's basically a terminal block and a few connectors for the DB9. Yeah, I'm probably going to change this significantly, but this is what I had in mind. And with the spider board, I have 8 drivers. If I want the Enrage Rabbit project carrot feeder, I need 9 drivers. So spider board by itself doesn't really work that well. So for the tool head, what I want to use is Huvud. So this is CAN bus driven toolhead PCB. It has the TMC2209 driver built in. It has the MOSFET for the hot end heater, fan control, etc. Everything built into this. So it's a pretty nice board, but it is out of stock, and based on the updates here, it won't be back in stock in quite a while. So I'm going to get my Voron 2 working with its current setup. It's just temporary wiring, don't worry about it, and it will probably be out on Friday. But yeah, in the long run, I want a toolhead PCB, and Huvud is one of the primary options. I know there are other boards out there, and I know there are some boards that are in development, but yeah, we'll see about that. Obviously, Huvud isn't in stock, so I have the time to think about it if I want to change my mind to a different board. But yeah, this is what I have in mind for now, and yeah, we'll see, I guess, down the line. I also want a CAN bus driven PCB for the A and D motors on the Voron 2.4, so I might have to custom design that at some point. The reason I'm not designing the toolhead PCB and that PCB right now is because I really don't have much electronics design experience. I mean, I did the ADXL345 MCU, but really that's about it, and that PCB is fairly simple compared to this. This is basically a whole controller board, so it's a bit risky in my opinion for me, but I don't know, I might design it at some point. We'll see. If there are no other options available, I might try. But right now, with the component shortage, that's not really a great idea anyway. So that's really all I wanted to show. So again, just to recap, this PCB on the toolhead on the Voron 0.1, and this between the motors on the Voron 0.1 as well as a breakout.
Again, again, this one could be changed significantly if I decide to go with SMD components and buck converters built in and stuff like that. Similarly on this one as well, this could change significantly as well, but this is the Tiny-M PCB as a just accessory board, so breakout for Raspberry Pi GPIO and fan control and PT100 Max31 modules. And this is just a very early thing for with the aim of what I just described, which is basically keeping the bedboard and the rest of them, switching them to CAN bus based stuff. And yeah, really, that's about it. So I hope this was interesting to you. I just wanted to show you things that are still in development. As I said, a lot of changes will happen to these down the line. I haven't ordered any of these yet, but still I think it is interesting enough. And as I said, that's it for this video, so thanks for watching.